The Autonomous Aerial System Group of Technical University of Munich proudly presents our work on the control of fully actuated aerial vehicles. In this paper, we compare two nonlinear dynamic inversion approaches, a model-based geometric controller and a sensor-based incremental controller. Both methods are implemented and experimentally evaluated on a fully actuated hexarotor platform to assess their performance, robustness, and disturbance rejection capabilities. The main contribution of this work is comparative experimental study of two nonlinear control approaches. Both methods are implemented on the same fully actuated aerial platform and evaluated under identical conditions to ensure fair assessment of their tracking and disturbance rejection performance. Additionally, to our best knowledge, this work provides the first experimental validation of a full pose INDI controller with explicitly decoupled translational and rotational dynamics enabled by a fully actuated multirotor system. This slide summarizes the experimental scenarios used to evaluate both controllers. We consider three representative cases. First, robustness to parameter uncertainty through a 50% rotor force coefficient mismatch. Second, a hover disturbance rejection comparison. And finally, wind gust disturbed tracking comparison. All tests are performed on the same fully actuated platform with identical gains and control frequency to ensure fair comparison between the geometric NDI and INDI controller. Experiment 1. Parameter uncertainty test. The first row shows geometric NDI controller and the second row shows INDI controller results. The highlighted regions in the plots on the right visualize a roll, pitch, and yaw step commands and the resulting tracking. The geometric NDI exhibits position tracking errors and noticeable attitude oscillations, whereas INDI maintains stable and accurate tracking throughout the experiment. Experiment 2. Hover disturbance rejection test. The top row shows geometric NDI and the bottom row shows INDI. The highlighted region indicates when the load is applied. INDI maintains position and attitude so well that the motion is barely visible, while geometric NDI exhibits clear deviations. To emphasize this difference, the audio in the video corresponds only to the INDI case. Overall, the performance gap is significant. Experiment 3. Waypoint tracking under wind gust. The first row shows the geometric NDI and INDI during waypoint tracking without a wind gust, while the second row shows the gust cases. The plot order is identical. Both controllers track well overall, but the geometric NDI exhibits slightly degraded attitude tracking under the wind gust disturbances. Thank you for your time.